Hi friends, I am Swati Dinkar Ghatge, Assistant Professor in Pedigree College Tasva. Today we will discuss semiconductors. Semiconductors are materials which have a conductivity between conductors and non-conductors. Non-conductors means insulators. That is, semiconductor shows properties in between conductors and insulators. For example, semiconductors of gallium, arsenic or pure elements such as germanium or silicon. Now we will discuss types of semiconductors. There are two types of semiconductors: intrinsic semiconductor and extrinsic semiconductor. First one is intrinsic semiconductor and second is extrinsic semiconductors. See here, semiconductors mainly classify into intrinsic semiconductors and second type is extrinsic semiconductors. Intrinsic semiconductors are nothing but pure form of germanium and silicon crystals. Extrinsic semiconductor again has two types, that is N-type semiconductors and P-type semiconductors. These extrinsic semiconductors are formed by adding or doping impurities in intrinsic semiconductors. Depend upon which type of impurity added, extrinsic semiconductors classify into N-type and P-type semiconductors. See here, N-type semiconductors form by adding pentavalent impurity. For example, pentavalent impurity atom, that is phosphorus, arsenic, etc. And P-type semiconductors formed by adding trivalent impurity. Trivalent impurity, for example, gallium, boron, indium, etc. Then we will see first type of semiconductors, that is intrinsic semiconductors in detail. See here, intrinsic semiconductors means inborn, naturally occurring, pure and basic semiconductors. The best example of intrinsic semiconductors are crystals of pure silicon and pure germanium. At low temperature, semiconductors basically insulators. That is, at absolute zero temperature, semiconductors acts as an insulator, but at high temperature they can conduct electricity. Such an electrical conductivity of semiconductor is called as intrinsic conductivity, and that solids or such solids are known as intrinsic semiconductors. Means intrinsic semiconductors at absolute zero temperature completely acts as an insulator, but at high temperature this intrinsic semiconductor property comes into that semiconductor material. For example, pure crystal of silicon atom. Pure crystal of silicon atom. As we know, silicon has atomic number 14. Its electronic configuration is 1s2, 2s2, 2p6, 3s2 and 3p2. It means that its valence electron is 4. That is, silicon atom crystal tetrahedrally linked with each other through its 4 valence electrons. Means by its silicon used by its 4 electrons forms 4 bonds with other 4 silicon atoms. See here. Silicon atom, this silicon atom tetrahedrally linked with 4 other silicon atoms by using its 4 valence electron. So there is no any free electrons at absolute zero temperature or at low temperature. Here, working mechanism of intrinsic semiconductor. At 0 Kelvin, free electrons are available because all the electrons involved in bond formation. All the electrons can't reach the conduction band, remains in the valence band. As there are 0 electrons in conduction band, so no electricity formation, means the semiconductor behaves as an insulator. That is, at absolute 0 temperature, all electrons of silicon, that is 4 electrons of silicon atom, engaged in bond formation with other 4 silicon atoms. So there is no free electron available for conduct the electricity, or all electrons remain present in valence band. As we know that there is 2 bands, that is, one is conduction band and second one is valence band. At lower side there is valence band and at upper side there is conduction band. If there is free electron, then electrons jump from valence band to conduction band. But at 0 temperature, all 4 electrons of silicon involved in bonding, so there is no electron present to jump valence band to conduction band. So no electricity conduction at absolute 0 temperature. As temperature rises to 300 Kelvin, the silicon atom excited and releasing electrons, and vacancy generated in that place. As we increase the temperature up to 300 Kelvin, silicon atom get excited and start to release its valence electron, and so the electron that is set free is the thermally free electron. The place of the electron left is the vacancy or the hole, and this electron gains some energy and crosses forbidden energy gap and reaches the conduction band. This migration is responsible for electricity generation. See here in this figure, this place from electron get excited, that place is called as hole, and the electron releases from that place is called as free electron, and that free electron is called as thermally free electron, because at high temperature this electron gets released from to silicon bond. At high temperature there is availability of free electron, so easily electron crosses this forbidden gap and reach the conduction band. So at high temperature intrinsic semiconductor can conduct electricity. Then this is all about intrinsic semiconductor, that is at absolute zero temperature intrinsic semiconductor are purely acts as an insulator, but at 300 Kelvin they become conduct electricity. That type of conductors are called as intrinsic semiconductors. Then second type is extrinsic semiconductors. Extrinsic semiconductors depends upon the presence of impurity in the crystals, that is by doping. Doping means mixing of trivalent or pentavalent impurity to semiconductors at high temperature. Means extrinsic semiconductors are formed by doping either trivalent or pentavalent impurity to intrinsic semiconductors are at high temperature. It means a semiconductor which is obtained by adding impurity atoms to the intrinsic semiconductor is known as extrinsic semiconductors. There are two types of extrinsic semiconductors, that is N type and second one is P type semiconductor. N type and P type semiconductors, these are two types of extrinsic semiconductor which are depends upon which type of impurity doped into that intrinsic semiconductors. Okay. Now we will see first type of extrinsic semiconductor, that is N type semiconductor. So in a pure semiconductor, that is silicon or germanium crystal, is doped by pentavalent impurity, for example phosphorus, arsenic, bismuth. Then 4 electrons out of 5 valence electrons bonds with 4 electrons of germanium or silicon. The fifth electron of the dopant is set to free. Thus, the impurity atom donates free electron for conduction in the lattice is called donor. It means pentavalent impurity means, for example, phosphorus. Phosphorus has outermost cell contains 5 electrons. 5 electrons. It means out of 5 electrons, 4 electrons form bond with 4 silicon electrons, silicon atoms electrons, and out of 5, 4 electrons of phosphorus involved in bonding with 4 electrons of silicon, and 1 electron remains free. That is fifth electron of the dopant, that is impurity atom, is set to free. Thus, impurity atom donates a free electron for conduction in the lattice. That is, that free electron responsible for conduction of electricity in N type of semiconductors. See here, since the number of free electrons increases by addition of an impurity, means as we increase the dopant atom, that is, as we increase the pentavalent impurity, there is also increases free electron in that crystal lattice. So that type of semiconductors are called as N type semiconductors. See here, here is phosphorus atom, that is impurity atom. This is silicon, at surrounding there is silicon. Phosphorus atom has total 5 electrons. Out of 5, 1, 2, 3 and 4. Out of 5, 4 electrons involved in bonds with silicon, surrounding 4 silicon atom, and 1 electron set to free. This is free electron of dopant atom. According to band theory, replacement of silicon by phosphorus atoms, the extra valence electron form new energy band called as electron donor band. That is due to extra valence electron donated by phosphorus atom, that is impurity atom, there is formation of new energy band, and that band is called as electron donor band, and which is formed in between valence band and conduction band. This electron donor band is very close to the conduction band, thus conduction of electricity is possible in N type semiconductors. See here in that figure, here is valence band, conduction band, and near to conduction band there is formed extra band, that is electron donor band, EDB, extra electron energy level, that is called as Fermi level. So electron can easily jump from EDB to conduction band, and that is that electron responsible for conduct electricity in N type semiconductor, that is N type of extrinsic semiconductor. Here we complete one type of N type semiconductor and intrinsic semiconductor. Thank you.